Hi everyone, my name is Alessandra Totti and I'm a PhD student in the Marie Curie Consortium Targeted Anti-Cancer Therapies, TACT, and I work in Heidelberg Pharma in Heidelberg, Germany. Today I would like to explain you what is an ELISA assay. ELISA stands for enzyme-linked immunosorbent assay. In the company, we work with ADC, which stands for antibody-drug conjugates. An ADC is composed by the antibody, which is linked to a toxin. The antibody drives the whole conjugate to the tumor cells, and the toxin gives the antibody the ability to kill the tumor cells.
Let's start explaining how an ELISA assay works. We have our 96 well plate and we coat the wells with a coating antibody or capture antibody that recognizes the toxin on our ADC. When we incubate the sample, the toxin linked to the ADC will bind to the coating antibody. Next, we will add the secondary antibody that will recognize the antibody part of our ADC and will bind to it. This secondary antibody is linked to an enzyme, HRP, horse-radish peroxidase, that after addition of a specific substrate will change the color in the wells, and then we can read the absorbance. We incubated a plate at 4 degrees overnight with a solution of our capture antibody. Next, we will do a blocking step to decrease a specific protein binding sites. We will use an automatic pipette with dispenser tip and our blocking buffer. Remove first the coating solution by tapping the plate on a paper towel and then apply the blocking buffer step by step. We use a solution of 3% bovine serum albumin in PBS. After 1 hour incubation at 37 degrees, we remove the blocking buffer and wash with a solution of PBS 0.05% twin. We wash 3 times to be sure to remove all the remaining blocking solution. We need to create a standard curve to be able to quantify the concentration of an ADC in our test sample. The standard curve is prepared by making serial dilutions of one known concentration of the ADC that we want to detect in sample buffer. Since our test sample is in mouse serum, we will also dilute the sample to reach the right range of concentration and avoid the background noise of serum. Always run ELISA samples in duplicate or triplicate. This will provide enough data for statistical validation of the results. After 1 hour incubation at 37 degrees, we wash again 3 times and we add the secondary antibody solution for another hour. We wash again the plate 3 times. We will then add the substrate. The substrate is TMB, tetramethylbenzidine, a chromogen that yields a blue color when oxidized with hydrogen peroxide by the horse-radish peroxidase. Protect the plate from light and incubate at room temperature for 20 minutes. After 20 minutes, we stop the reaction by lowering the pH. We do so by adding sulfuric acid to the wells. As you can see, the addition of sulfuric acid shifts the color from blue to yellow. The brighter the color, the higher the concentration of ADC in the wells. Final step, we read then the absorbance at 450 nanometer and 550 nanometer wavelength in a plate reader.